Okay, hi. In this session, we're going to look at two types of equations, linear equations and rational equations. The reason that we're bringing them together is they are somehow similar, and then you will see the similarities between them. When we talk about linear equations, you are we are talking about a straight line, either rising or descending. That's what we mean by linear equations. And you have seen it in 096. That's why we have the slope that is constant, meaning what? The slope never changes in linear equations, okay? So y is equal to mx plus b is a form of a linear equation. And a rational equation has also some kind of similarity with it, except that we have denominators other than 1. So first let's start with examples of linear equation. A linear equation is of the form ax plus b is equal to 0, where a and b are constant numbers, but x is a variable. And we always make a restriction a cannot equal to 0. Because if a is equal to 0, then it stops being a linear equation, it only becomes a constant b is equal to 0. Okay? So, probably let's start from the simpler one. So if you have 4x plus 12 is equal to 0, and then you are asked to find x. And you know how to do that. You're going to shift 12 to both sides. Then you have 4x is equal to minus 12. And if you divide both sides by 4, this will give you x is equal to negative 3. Okay? And by linear equation, most of the times, we have only one solution because x is of the first degree. Okay? So let me do some important examples. And suppose now you have 2x plus 3 is equal to 17. This is also another instance of a linear equation. What you need to do, use the order of operation. You take 3 away, and then you divide both sides by 2. X is equal to 7. And the beauty about this is you can plug in the value that you have just to make sure that this plus this would equal to 17. And 2 times 7 is 14. 14 plus 3 is equal to 17. So it's the same chain. Okay. Now, let's use some linear equation that involves more than 2 steps. Minus 17 is equal to 13 minus 3 x plus 2. Okay. Okay, this is just to test our knowledge of order of operation. So you remember the PEMDAS thing. So first we have to make sure to simplify the one inside the parentheses, so it will help us get rid of the parentheses. So I'm going to distribute 2 to everything inside for the first one. So you have 2x. If I distribute 2 to everything inside, I get 2x minus 6. Then bring down negative 17 is equal to 13. This time be careful. You're not only distributing 3, you are distributing negative 3. So negative 3 times x will give you negative 3x, and negative 3 times 2 gives you negative 6. So once you get rid of the parentheses, now what you need to do is just combine like terms. So you have negative 6 and negative 17. So you have 2x, add them together, you end up with minus 23. Do the same thing here. 13 minus 6 is 7. 7 minus 3x. Okay. So it's telling us 2x minus 23 is equal to 7 minus 3x. We're not done with bringing like terms together. So probably I would add, because I want to bring the x's on this side, so I'm going to add 3x. Then you have 2x plus 3x is 5x minus 23 is equal to 7. I'm done with the x's. Now all I need to do is what? Move negative 23 to the other side, meaning I'm adding 23, 23, then you have 5x is equal to 30. Then divide both sides by 5, x is equal to 6. Again, just to self-check, plug in the value of x, which is 6 instead of x, and see whether the equation works out. Okay? So, that is basically what we mean by solving a linear equation. Find x. Okay. Now, let's look at the rational equation. What do we mean by rational equation? Suppose you have x plus 2 over 4 minus x minus 1 over 3 is equal to 2. This, in essence, is a linear equation. The only difference is we have a denominator other than 1. That's why we call it rational equation. So the first step that you need to do is always fractions are annoying to solve an equation. So we got to get rid of them. One way of getting rid of them is to find the least common denominator. And here your least common denominator is 12. 4 times 3. So the second step that you're going to take is multiply each term by the least common denominator. That will help you get rid of the fraction. So this is how we're going to do it. So 12 times x plus 2 over 4 minus 12 times x minus 1 over 3 is equal to 12 times 2 over 1 or 2. Okay. Now, don't distribute 12 yet, because our task is what? Our ideal thing is to turn this into an equation without a denominator. So 12 into 4 goes 3 times, so I'm going to write 3 times x plus 2 minus 12 into 3 goes 4 times x minus 1, and 12 times 2 is equal to 24. This doesn't change the value that we have here. This and this are similar. In fact, it is the same equation. We brought a new item, but we used it what? We multiplied that item with each term, so that means what? It didn't change its value. So let's go ahead and distribute this. So you have 3x plus 6, and then you have minus 4x, minus 4 times minus 1 is plus 4, which is equal to 24. Be careful of the minus sign. Sometimes we overlook it. Now combine like terms. 3x and minus 4x would give you negative x, right? And then 6 and 4 gives us plus 10, which is equal to 24. Then take away 10 from both sides, so you would have negative x is equal to 14. But that's 14 is the value of negative x, but we are looking for what? Not negative x, but x. But you can do what? Divide it by negative 1, then x is equal to negative 14, and you're done. Okay? Okay. Probably let me add one more example of this. Then we have, mind you, the first one that we did is The denominator is just a constant number. But now we're going to change this 1 over x is equal to 1 over 5 plus 3 over 2x. Now, here we have to be cautious because there is a restriction. You know, anything over 0 is undefined, right? 1 over 0 is undefined. So if you look at our equation, I'm going to wipe this out because you know anything over 0 is undefined. So before we even start solving this equation, we have to make the statement, whatever x we can find, that x cannot equal to 0, because if x is equal to 0, this becomes undefined, and this also becomes undefined. And we don't want to do that. The next step that we're going to do would be find the least common denominator. The least common denominator between x and x is x. But we have 5 and 2. So just multiply both of them, so you have 10x. This is your least common denominator, 10x. So we're going to do the same thing that we did earlier. Multiply each term by the least common denominator, which is 10x. So do 10x times 1 over x is equal to 10x times 1 over 5. See, I'm distributing the least common denominator to each term. 10x times 3 over 2x. Okay. Now let's go ahead and simplify this. The x and the x cancel out, so all I'm ending up here is just 10. And then let me simplify this. 5 into 5 goes 1 time, 5 into 10 goes 2 times, so you end up with 2x. Okay. Now 10x and 2x. The x and the x cancel, the 2 and 10, you're going to get 5 on the top. So this ends up with 5 times 3, which is 15. And now we're going to solve. So if we find x, as long as it is not 0, then that would be the solution. So bring minus 15, right? 10 minus 15 is minus 5, is equal to 2x, right? Then divide both sides by 2, so you end up with x is equal to negative 5 over 2. It's not 0, therefore that is your answer, okay? Let me do another one. You have now x over x minus 3 is equal to 3 over x minus 3 plus 9. Okay, this is also another instance of a rational equation. Look at the denominator. Then ask yourself, before we find the LCD, for what value of x is x minus 3 0? Meaning what if we plug, if x is equal to 3? If x is equal to 3, both this and this become 0. So therefore, x cannot equal to 3. Otherwise, it makes it undefined. Once we do that, then find the least common denominator. Here it's easy. The least common denominator is x minus 3. Do the same thing that we did earlier. Multiply each term by the least common denominator, which is x minus 3. So do x minus 3 times x over x minus 3 is equal to x minus 3 times 3 over x minus 3 plus 9 times x minus 3. Okay? Now, the x minus 3 and the x minus 3 cancel out. We have x. x minus 3 and x minus 3 cancel out. We only have 3 plus. Now go ahead and distribute 9 to everything inside. 9 times x is 9x. 9 times negative 3 is negative 27. Right? So now you have, let's bring these two together, 3 and negative 27. So meaning what? Combining like terms. So you would end up with 9x minus 24, because minus 27 plus 3 is minus 24. Now move x to this side, right? Minus x, then 0 is equal to 8x minus 24, right? Add 24 to both sides, 24. Then you have 24 is equal to 8x, right? Divide both sides by 8, divide both sides by 8, then you end up with 3 is equal to x. In the beginning, we said x cannot equal to 3, whatever value we get. We ended up with x is equal to 3. So meaning what? This rational equation has no solution, because x is equal to 3. So your answer would be no solution. Okay. All right. That's why, which is important to always look for a restriction in rational equation. Okay. Let me do another one. So I'm going to throw some concepts, so when you do the assignments, then you would know what it is. Suppose, let's say you have 2 times x plus 1 is equal to 2x plus 3. And you are asked to solve this. These are special type of equations, even though they are linear equations. So go ahead and do that. 2x plus 2 is equal to 2x plus 3. If you look at these two terms, this doesn't make sense. 2x plus 2 is equal to 2x plus 3. In fact, to make it more visible, get rid of 2x, because you have 2x on both sides. Look what you end up with. 2 is equal to 3. This is a contradiction. 2 is not equal to 3. So when you see this kind of equation, again, that would be no solution. Okay? Okay. And also you could face similar but not the same. Look at this equation. 4x plus 6 is equal to 6 times x plus 1 minus 2x. This is the same equation written in different form. But let's just make a few steps, do a few steps, and you can see what I mean. Distribute 6 to everything inside. So this becomes 6x plus 6, and then you have minus 2x, right? Combine like terms, so you end up with what? 4x plus 6, 6x minus 2x is 4x plus 6, meaning what? It is the same expression on both sides of the equation. When you see this, then your answer would be what? All real numbers. You can plug in any value of x, and it still can be a solution, meaning what? Or you can say from negative infinity to infinity. Okay. I think that concludes our session on linear equations and rational equations. Our next session will be on complex equations.